Now we are going to discuss about the semiconductor electronics. The title itself says that it is an electronics based on semiconductors. What is a semiconductor? Solid materials classified into three types on the basis of their electrical nature. If the electrical nature is the basis, they are classified into three types. First one is insulators, second one is semiconductors, third one is conductors. And this list is also like this: conductors, semiconductors and insulators. But there is an order to write this one from insulator to conductors or conductors to insulator. There are two properties: conductivity and resistivity. Second one, resistivity. Conductivity symbol is sigma, resistivity symbol is rho. These are the main important phenomena that are exhibited by a solid state material. So, what is an insulator? We know that insulators are electrically, there is no possibility to pass the electricity through that. What is the reason behind this classification? Not only the electrical nature, there is a theorem called band theory of solids. What is this band theory of solids? To understand this concept and to apply this concept to this classification, we should know about the Bohr's atomic model. So in Bohr's atomic model, as a nucleus contains the protons and neutrons, as electrons are revolving around the nucleus in energy levels. That energy levels are discrete energy levels. The other name of that energy levels is called orbitals. So S, P, D, F, like that, the orbitals are continued in the order. So what is this orbital? And these orbitals are called as energy levels. The outermost orbital contains some n number of electrons. Those electrons are called valency electrons. These valency electrons are the one of the important point to understand this concept. Now we will see how these valency electrons are playing a key role for this classification of solid state materials on the basis of their electrical nature. So what is the band theory of solids? So this band theory of solids, we should see the electronic configuration in an atomic structure. Let us suppose sodium, one of the metal. Its atomic number is 11. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. So we can write this one: 1s2, 2s2, 2px2, 2py2, 2pz2 and again 3s1. Means there is a 3s orbital which is called as outermost orbital. It contains only one electron around the nucleus. So what are the energy states? 4, 1, 2, 3, 4. So fourth orbit, which is named as 3s. So at that 3s, only one electron is present. This electron is loosely bounded with the nucleus of the sodium atom. Loosely bound means the influence of the nuclear force on this electron, which is in 3s orbital, is very, very less. Because of that, the electron which is present in this 3s orbital is freely available to react with the other materials. That's why these electrons are called valence electrons. If you want to see the structure, so it will be like this. Nucleus of the sodium contains proton and neutron, 1s, 2s, 2p, 3s. This is 1s, contains 2 electrons. This is 2s, contains 2. 2p contains 6. 3s contains only 1. 1s, 2s, 2p, 3s. So as the distance from the center of the sodium nucleus to the 3s1 orbital is far. So as the distance goes on, the electrostatic force is inversely proportional to square of the distance between them. Fe means as R going to increase, Fe going to decrease. So the electrostatic force from the nucleus to the electron is very less. That's why this electron is freely available to react with the other materials. Such like this, the electrons are called valence electrons. There is an energy band which is filled with valence electrons. That's why that energy band is called valence band. Suppose, to understand this concept, we can assume this one like this also. Suppose there is a solid material. So there is a solid. We know the nature of the solid. There is an overlapping of the molecules, because in solids there is no such a gap between the molecules. And chemically we can say that the intermolecular gap between the solid materials, or the intermolecular force between the solid materials is very much, because the molecules are tightly fixed with each other within the solid lattice. Lattice means a position of the shape. So in case of this overlapping, means all the atoms are fixed and like this, very close to each other, all molecules. We will see some 3 layers. Suppose if this is the solid state, what we can understand is the electrons which are in the orbits, there is no such an expansion for these orbits. These orbits also overlap each other, because according to the Bohr's concept, these orbitals are said to be energy levels. So these energy levels are going to overlap on each other, because this is a solid. Suppose there is an energy band which is filled with valence electrons, that is said to be valence band. And there is one more band that is said to be conduction band. The gap between this valence band and conduction band also plays the key role to divide the solid materials into conductors, semiconductors and insulators. Now we will see the schematic diagrams of this gap. So first one we will see like this. This is valency band, a valence band, we can say like this. This is conduction band. So what is the meaning of valence band? There is an energy band or energy level which is filled with valence electrons. And the remaining electrons are said to be conduction electrons. That's why the energy level which is filled with the conducting electrons is called conduction band. So the energy of this valence band is EV. The energy of this conduction band is EC. This is a simple block structure of the bands between the atoms. So conduction band and valence band. This gap is playing the key role to classify the solid state materials into electrical nature. Suppose if these two bands are overlap with each other or overlap on each other, so this is energy conduction, this is energy valence, this is overlapped. So like this we can say. Whenever the valence band and conduction band overlapped on each other, those solid state materials are called conductors or metallic conductors. In general view, we can say that metals. So by this point, we can say that metals are the best conductors among the solid state categories, because in metals, okay, the valence electrons will be there.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.